Question number 23. Planet X has a gravitational field strength of 18 Newton per kg. This is Gx. Okay. Planet Y has the same density as X, which means what? Rho X is equal to rho Y. But 3 times the radius of X. 3 times the radius of X. Ry is equal to 3 times X. Okay. What is the gravitational field strength at the surface of Y? What is Gy? Gy, that's what's been asked. Now we know G is equal to Gm divided by R square. But since it's a mass can be related to density as mass by volume equal to density, our mass should be equal to volume times density. What is volume? For a sphere it should be 4 by 3 pi r cube into rho. Let me substitute it over here. I get G is equal to G into what is mass? Mass is volume 4 by 3 pi r cube into rho divided by r square. So this goes away and this cube goes away. So what am I left out? 4 by 3 pi g rho multiplied by r. All these are constant, so I put it inside a bracket over here. Okay, so what is it we have inferred? G proportional to r, right? So which means gx by gy will now be equal to rx divided by ry, because this will cancel. If I substitute here, it will be cancelling over here. I get rx by ry. Now let us substitute. What is ry? Ry is equal to 3 times rx. So I will just retain like this over here, and this will be 3 times rx over here. This goes away, so I get the answer is 1 by 3. Okay, so now what do I need? I need the value of gy here. Okay, so gx by gy equal to 1 by 3. Gx equal to 3 times gx equal to gy divided by 3, or gy is equal to 3 times gx. Now what's the value of gx? Gx is 18. Okay, so therefore I'll substitute this 3 into 18, which should be equal to 54 Newton per kg. Okay, it's given Newton per kg, right? But here it is in meter per second square. We know that gravitational field also has a unit of meter per second square. Acceleration due to gravity has the same unit, so it is 54 meter per second square. Answer is C.